Hello everyone, this is video 2.5. This is the last video for chapter 2, and we're going to be talking about percents. Now, we're not going to be going a lot of depth into percents. A lot of that we'll save for chapter 7 when we get to ratio and proportion. So we'll do a lot more mechanically with percents then. But we are going to define percents, look at some ideas around percents, and just sort of introduce concepts of percents. We'll do some operations with percents from an equivalent fraction standpoint, but a lot of the mechanisms with percents we'll look at a little bit later on. So let's get started. So the first thing is to define what a percent is, and a percent is going to be some part out of 100. And the clue is in the name. Per, that's for every, and then cent is 100, like centipede or centimeter. So we know that we're dealing with something that's out of 100. So if we say 15%, then we know that we're talking about 15 out of 100. So for every 100 of something, 15. So for every $100 that you owe, you have to pay an extra 15. So that'd be 15% interest. So there's a lot of examples dealing with percents that we can talk about, and not every case are we going to have the 100. So this is a little bit of a conceptual sticky point. So if we were to talk about, how many books on a shelf are math books, and there's 10 books and three of them are math books, well, we'd say, well, 30%. Well, why? Because if we had 100 books, and then you have to kind of stop and sort of recognize, well, we don't have 100 books. Now, the the extension of that would be the equivalent fraction piece. So if I were to take these 10 books and I had them 10 times, then I would have 100 of them. And out of that 100, then 30 of them would be. So there's an equivalent fraction piece to this to say, well, 3 out of 10 is the same as 30 out of 100. So while we don't have the 100 pieces, we can think about the equivalency to if we did. And so that's a little bit of a leap that you have to take with students. You have to kind of show them how to get from here to there, that we have this as potentially tangible objects and this as an abstraction on those tangible objects. But again, if you've built equivalent fraction fluency up to this point, it's not as much of a step as we might think. So let's look at some examples of problems. So there's really three things that we can be looking for. We can be looking at the portion, we can be looking at the whole, or we can be looking at the percent. And you'll see a lot of sort of tricks and mnemonics and schemes for how to sort of remember this. A really common one that you'll see teachers use is they'll use this little triangle here. And again, like I don't mind that as an extension of understanding what's going on, but it should not take the place of the actual mathematics. So we're looking at how much is 12% of 300. So in this case, we know here we're looking at the whole, we're looking at the percent, and then what we're trying to find is this portion. Now, I want to caution you, a lot of teachers like to talk about this of, and they'll say that when you see this of, that lets you know that you're working with the whole afterwards. And in a lot of problems, that is the case. In a lot of problems, to be fair, the whole does come after the word of. The problem is, not every problem has the word of. And so if we have students sort of understanding that just look for that word and then whatever comes after it, then they don't know what to do when the word isn't there. So it's a whole lot better to actually understand the problem uh, than look for words that may not always be there and they don't have to be there. The percent, we have a pretty good clue because it has a percent sign. Um, the sign is going to be there, so we know the percent. The of does not always have to be there. So we're looking for how much is 12% of 300. So this is our portion. So in doing this problem, we're going to look at this from an equivalent fraction perspective. So what we know is that 100% is 300 because our whole always has to be 100%, right? That is by definition what a whole is. It's the whole thing. So our 100% is 300. Now, because of this, we can also figure out that 1% would have to be 3. And so we can think of this, like I said, as equivalent fractions. And so we've got 100% is 300. So if we divide by 100, then we have 1% is 3. And I want to keep this percent sign so we don't mistakenly think that 1/3 is happening in this problem. It's not 1/3. It's 1% is to 3. Um, so in a way, this kind of becomes a little bit of a ratio because we're comparing two numbers. This isn't really part to whole anymore. We're thinking about this kind of, this is acting sort of more as a ratio, which again, we'll talk about more in chapter 7. But operationally, it's behaving like a fraction, so we can kind of blur the line a little bit. And so now what we want, the problem was asking about 12%. And so we can multiply this by 12 and multiply this by 12. And so we get 36. And so that's where this little triangle comes from when you see it. You'll see this written sometimes where you have a percent, you'll have of, and you'll have part. And the idea behind this is that you look at the relationship between these things. So if I want the part, then I can just multiply the percent times the of. Now, again, the of isn't always there. The problem, you have to convert this percent to a decimal. So really we're multiplying 0.12 times 300 to get 36. Again, it's mechanical without any understanding. There's too many ways to make a mistake. I get what the triangle is meant to show, but if there's not meaning attached to it, then it's just sort of pointless. It's just as easy to work through this as sort of like unit fraction, as a unit fraction problem, and equivalent fractions to get the answer, and where you kind of understand a little bit more of what's going on. So this is our first example of finding the portion, finding the part of the whole. So now let's look at a problem where we're trying to find the whole, the 100%. And so now in this case, we have 3% is 15. And so similar to the previous problem, we want to know the whole, and we know that our whole is 100%. But what we're given is that 3% is 15. So 3% is 15. So again, we're going to get this down to a unit fraction, which is going to be nice because 3 doesn't divide into 100 very evenly. Now, if for whatever reason you're compelled to just multiply the 3 and the 15 by 33 and a third, you certainly can. But I'm going to work this as a unit fraction, or as a unit rate, rather. So I'm going to divide by 3 and then divide this by 3. And so if 3% is 15, I know 1% is going to be 5. And so then if 1% is 5, I'm going to multiply this by 100. And so I know 100% would have to be 500. Again, I can write this out like equivalent fractions and say 3% is to 15, 1% is to 5, and so 100% is to 500. So the same thing, just written in a slightly different way, but mechanically it's the same idea. Times 100 and times 100. There you go. So once we've identified this as a whole, again, this crucial idea that the whole is 100%, go through a unit percent and then find how much our whole is. The last problem we're going to look at is finding a percent. And so now we have, this is the part, and this is the whole. And so we know this is our smaller amount, this is our whole amount. And again, we're going to use the idea that our whole is 100%. And so since we know that 8 is our whole amount, we know that 100% is 8. And what we want is to find out what percent is 5. Now, in the previous two problems, I was kind of nice and avoided any sort of decimals. Everything sort of divided out nicely. But in order to get the unit rate here, we're not going to be able to do that. So when we divide this by 8 to get 1, we're going to have to divide this 100 by 8. And as you probably know, 100 is not evenly divisible by 8. We get 12.5%. So it's a half. It's not the worst thing, but it's not really feasible to go through all these problems and not have a decimal here or there. So we've got 12.5% is 1, and so now if we multiply by 5, we multiply this by 5, and so we get 62.5%. Again, there's a lot more mechanically that we can do with percents, but we're going to hold that off until we get to chapter 7. Think about these problems, and we're going to talk about these problems in this chapter, I said, from the perspective of equivalent fractions, and especially as you can see from these three examples, using this unit, using this unit rate, where we're going to make this equal to 1. It makes these problems a lot easier. We know that whatever this is, we're going to divide by that because that'll give me the 1. And then wherever I need to go, I'm just going to multiply that by that because 1 times that number is going to give us that number. So this process becomes a lot more consistent, becomes a lot more regular. It's a lot more predictable, which is good. So as a checkpoint problem, we've got a class. It's got 15 girls and 10 boys. So I want you to think about what percentage of the class is girls. Now, the answer is not 150%. So that would probably be an incorrect answer I would look for quite a bit. So be thinking about what your part is, what your whole is, and then how to find the percent from that. And like always, if you have any questions about this problem, we can talk about it in class, or let me know if you have any questions. All right, thanks.